Quadratic inequalities are kind of cool because they're a conglomeration of a lot of the stuff that we've done so far this year. They have inequalities in them, which were those symbols less than or equal to, greater than, and greater than or equal to. When we graph them, we use dotted lines or solid lines. And when we graph them, we need to think about shading. For these guys, we shade below. For these guys, we shade above. And then, with our quadratic inequalities, we're also going to be thinking about something called critical points. The critical points of a quadratic are the X-intercepts. We spent a lot of time finding the X-intercepts when we were solving. So we are going to take a little bit of stuff from earlier in the year, a little bit of more stuff from earlier in this project, and we are going to look at those together for quadratic inequalities. We're going to start out by looking at some graphs. We wanted to graph the parabola y is greater than or equal to x plus 2 all squared minus 3. I'm going to draw a grid. According to this vertex formula, my vertex is at -2, -3. My parabola opens up, and a is 1, so it's going to go over 1, up 1, over 2, up 4, and so on. Now, if we look at our symbol says it's greater than or equal to. So when we draw our line, it is going to be a solid line for the parabola. Now we are shading for where it is greater than, so we're looking for the y values that are greater than the parabola. That means they're above the parabola. So when we shade, we're going to shade above the parabola like that, and we're done. That was graphing a quadratic inequality. Let's graph just one more. We have y is less than -x squared plus 4. This one is also in vertex form, and I know that it is up 4, and a is -1. So that means I go over 1 and down 1, over 2 and down 4. Now we need to decide what kind of parabola we're going to draw. This one is just less than, so it is going to be dotted. And then we need to figure out where to shade, and in this case we're shading below, so we are just going to shade below, because these are all the y values that are smaller than the parabola. Now let's say we wanted to check to make sure we shaded in the right place. We could choose a point in our shaded region to see if it made it true. I'm going to choose the origin, 0, 0. I'm going to test 0, 0. If we test 0, 0, that's going to be 0 is less than -0 plus 4. So 0 is less than 4. Is that a true statement? Yes. So our graph is correct. So graphing quadratic inequalities just means graphing the parabola and making sure you shade and use the right type of line, whether it's dotted or solid. Solving quadratic inequalities is a little bit trickier, and we can do that using, like I mentioned before, those things called critical points. The critical points of a quadratic are its x-intercepts, and that means its solutions. So before we can actually figure out what x squared plus 2x minus 8 is less than 0 works out to be, we have to find those critical points. You can do this using any of the solving methods we used. You can solve using square roots. You can solve using complete the square. You can solve using factoring, and you can solve using the quadratic formula. I like to try factoring first because for me that's usually the faster method. If we were to do factoring, right now we're looking for things that multiply to be -8 and add to be 2. 4 and 2 might do the trick. Which one would need to be negative to get me a positive 2 when I add the 2? So that means we have factor form x plus 4 and x minus 2, and we're looking for where it's less than or equal to 0. Now we can find our critical points. Our critical points are going to be x equals -4 and x equals 2, since those are the x-intercepts. Now, to figure out what intervals are true for this solution, I'm going to draw a number line, and on my number line I'm going to draw my 2 critical points. To figure out whether those critical points are included, we need to look at the sign. It's less than or equal to. So think back to your inequalities. If you had a less than or equal to, you had a solid colored in circle, closed circle. So the endpoints are included. Now, we actually have a number line here going on. And if we were to put numbers in here, 0 would be somewhere in between here, and then like 3 would be over here, and negative 5 would be over here. So we're going to test these different intervals to see which one makes this inequality true. To test them, we're going to plug in some value in this part, or the middle part, or the right part, and see what sign they work out to be. So let's start with on the left. That's where I usually start. Let's pick a number that is smaller than negative 4. I already have negative 5 marked, so let's use that. If we plug that into our equation, we're going to have negative 5 plus 4 times negative 5 minus 2. Well, negative 5 plus 4 is negative 1, and negative 5 minus 2 is negative 7, so that's positive 7. And when I'm trying to solve an inequality, all I care about is how it compares to 0, so all I care about is the fact that this interval is positive. Now let's choose something that's in the middle. 0 is the best choice. So 0 plus 4 and 0 minus 2. All I'm doing is plugging into that original factored equation. I end up with 4 times negative 2, which is negative 6. Again, really all I care about is the sign, and this is a negative part. So if I were to graph this, that part would be below the x-axis. Then last, I need something bigger than 2, 3. 3 plus 4 times 3 minus 2 gets me 7 times 1, which is 7, which is positive. Now, I am looking for the places where the parabola is below 0. So think about what this parabola would look like if we were going to graph it. Those are the x-intercepts, and it is below in between. I'm looking for that place where it is below, and that interval is in between our 2 critical points. We can write our solution in interval notation, negative 4 to 2. Any number in between these is where where the parabola is below the x-axis, where the parabola is less than or equal to 0. So we're going to use interval notation to write our solutions, since just like the other inequalities, there's not just one answer, there's an interval of answers. Our last example got a little bit messy there at the end. We were learning a lot of new stuff, so we're going to apply that to this new problem. We're looking for the critical points of this parabola. Find the critical points means we need to find the x-intercepts. To find the x-intercepts, more often than not, we need equals 0, at least if we're going to try to factor. So I'm going to subtract 12x from both sides. That means we're going to have x squared plus 15x. Giving you guys wait time. Everybody's just waiting for me, though. Is greater than or equal to 0. Now, I'm going to choose to factor this one. I see that, yeah, I only have 2 terms, but they both have an x in them. So I can factor out an x, and I get x plus 15 is greater than or equal to 0. We'll set both of your factors equal to 0. We get x equals 0. We get x plus 15 equals 0. So x equals negative 15. Those are my 2 critical points. That's what's going to go on my number line. I'm going to mark 0, and I'm going to mark negative 15. So we're going to be looking at those 3 intervals created by these 2 points. First, I need to think if these 2 points are included or not. Since it's e equals 2, they are, so I'm going to color them in. Now we need to select a number that is smaller than negative 15, a number that is between negative 15 and 0, and a number that is larger than 0. Doesn't matter what you select. So let's choose negative 16. Now I'm going to plug negative 16 into that equation. We're going to get negative 16 times negative 16 plus 15. Well, that means negative 16 times negative 1, which is a positive 16. That means for this interval, it is positive. The graph would be above. Now let's look at the other interval. I'm going to choose something really small, like negative 1. That works out. So now I'm going to do negative 1 times negative 1 plus 15, which is negative 1 times 14, which is negative 14. That means this interval in between is negative. We choose something on the other side. Let's choose 1. That would be 1 times 1 plus 15, which is 1 times 16, or 16. So that's positive. Now, if we look back at our original problem, the original problem says we are looking for the interval that is greater than, or in this problem, greater than. We never changed. So we're looking for where the parabola is above the axis. Since this has a positive a, that's what the parabola would look like. Where it's above, it's where it's positive. So this is actually two intervals. The interval from negative infinity up to negative 15, and the interval from 0 all the way to infinity. So this one has two parts to it. Negative infinity up to negative 15 with a bracket, and it has 0 to infinity. To take intervals and put them together, we use this union symbol. That means it's both intervals. They're both part of the answer. Let's go ahead and find the solutions to this inequality. When we find the solutions, that means we're looking for the critical point. So we need to find them by factoring, by using the quadratic formula, or by completing the square. I'm going to try factoring first, but I remember that when we factor, we can't have that negative sign there. So let's go ahead and let's factor out the negative first before we do anything else. X squared minus 6x plus 9 is greater than 0. Now you have two options. You can choose to get rid of that negative sign, or you now and do a little bit of work, or you can wait and deal with it later. If you were to get rid of it now, what that means is you would be dividing both sides by negative 1. So that way you would really just have to worry about x squared minus 6x plus 9, because it's negative and that negative 1 can cancel out. And 0 divided by negative 1 is still 0. Here's the trick though. Remember, when you multiply or divide by a negative number, your inequality symbol flips. So we're actually going to be solving the inequality. X squared minus 6x plus 9 is less than 0. Now that we have that figured out, I'm going to kind of ignore that top part. We did a lot of changing. This is the problem I'm going to solve. So to solve by factoring, we're looking for numbers that multiply to be 9 and add to be negative 6. 3 and 3 multiply to be 9. Negative 3 and negative 3 multiply to be 9. It's the negative version that works for the 6. So we're going to have x minus 3 times x minus 3 is less than 0. So this problem really only has one critical point. The critical point is x equals 3. So I'm going to draw that on my line, and I'm going to consider, is this thing included or is it not included? In this case, it's not included, so my 3 stays an open circle. Now, I only have two intervals to choose from for my testing. I'm going to test the interval to the left first. I'm going to choose 0 because to me that's the easiest. 0 minus 3 times 0 minus 3. That means I have negative 3 times negative 3, which is a positive number. Now let's go on the other side. 4. 4 minus 3 times 4 minus 3 means I have 1 times 1, which is another positive number. Now remember what we're solving. We're solving x squared minus 6x plus 9 is less than 0. Is there any place where this thing is negative? And does it even work at the critical point? No. So this problem has no solution. We can write 0 with a slash through it. There's no solution to this problem. If the inequality sign were different, then our answer might look a little bit different. But for this problem, we're stuck. No intervals work. I'm going to admit I'm using this inequalities lesson as a mini factoring review as well. But this is the last one, I promise. We're going to find the critical points of 4x squared minus 9. 4x squared minus 9 is one of our special cases. What is 4x squared minus 9? It's a difference of squares. So when we factor this out, we can use our special difference of squares rule, which says that the square root of the first one, square root of the second one, and because it's a difference, I need them to multiply so that one of them's negative and one of them's a positive. So these are going to help us find our x-intercepts, our critical points. We have 2x minus 3 equals 0, and we have 2x plus 3 equals 0. For the first one, we're going to add 3 to both sides, so you get 2x equals 3, so x equals 3 halves. Subtract 3 from both sides on the other one, so you get 2x equals negative 3, so x equals negative 3 halves. So on our number line, we can graph negative 3 halves and positive 3 halves. Now you need to look at that inequality symbol at the beginning. Are those two endpoints included? No, so I'm going to leave them as open circles. Now we need to choose some test points and try them out, see if they work. I'm going to choose something smaller than negative 3 halves. Negative 3 halves is negative 1.5, so we could choose negative 2 if we wanted to. So we're going to have 2 times negative 2 minus 3. And we're going to multiply that by 2 times negative 2 plus 3. 2 times negative 2 minus 3 is going to be negative 7. 2 times negative 2 plus 3 is still going to be negative. You're going to have a negative times a negative, which is a positive. Now let's choose something in between. Let's choose 0 because that's the easiest. We're going to have 2 times 0 minus 3 times 2 times 0 minus 3. So we're going to end up, plus 3. So we're going to end up with negative 3 times positive 3, which is negative 9. And then choose something bigger than 1.5, so that would be 2. 2 times 2 minus 3 times 2 times 2 plus 3. Well, that's going to be 4 minus 3, which is 1, and 7, so I'm going to have another positive number. Now, I'm looking for where it is greater than, so that means I'm looking for where the parabola is above, and that would be on these two intervals right here. Sometimes it's just one interval, sometimes it's two. So when we write our final solution, we're going to go from negative infinity to negative 3 halves, and we're not going to include it, so we're going to use parentheses. Then we're going to start up again at positive 3 halves, and we're going to go to infinity. That's where the parabola is positive. So solving quadratic inequalities is taking all of the stuff we learned before, remembering where to shade, remembering what those inequality symbols mean, and then it's mostly about finding the critical values or finding the x-intercepts. Once you test points in between those x-intercepts, you can determine which intervals are part of your solution.